Today is the 20th of November. This is the Business Intelligence lecture in Wirtschaftsinformatik. We will today look at a machine learning algorithm called support vector machines. Or also called SVM. Okay. The goal is given a set of labeled data, find the best separating line for 2D or plane for 3D or hyperplane for more than 3D. Okay. So this is the goal. The goal is to separate the data. Okay. For that, we need to implement support vector machines. We need, of course, label data. We need to know to which group the data belong. Okay. And because we are measuring distances, we need to check if normalization is needed. Okay. So we have an example. Imagine we have some data from 6 people. The variable x is the weight. Okay, so we have 50, 60, 68, then 85, 90 and 92 kilo. Okay, and then we also have the height in centimeters, 155, 160, 150, 175, 182 and 192. And then we say, okay, these groups belong to this data belong to 2 groups, group 1 or group A. Okay, so this is going to be A1, A2, A3, maybe feminine, woman. Okay, and this is B1, B2, B3, maybe men. Okay, So these are the data, and we want to separate the space of weight height depending on this data, so that when a new data set comes, we know where to place it. Okay, so this is one example. Let's implement support vector machines with this example and see what it means. Okay. Good. I will, the first step always, this is an algorithm, so it has steps. The first step, and it has to say these steps are not the steps that Python follows, are not the most efficient, but are the easiest to understand. So I explain it this way. So the first step is to have a graphical representation of the data. Okay, so this is easy. Let me paint the space, the face space here. I have the y-axis, I have the x-axis. Then I have here 50, 60, 70, 80, 90, okay? And then here I have 150, 160, 70, 80, and 190. And then I represent the points. So the first one is 50, 155. So this is here, A1. Then 60, 160. This is A2. Then 68, 150. Then A3. Then 85, 175. Somewhere here, B1. 90, 182. Somewhere here, B2. And 92, 192, somewhere here, B3. Okay? So this is the first step. And of course we know this is one group, this is other group. Okay? We want to find what is the line that separates the two worlds. One world, two worlds. Okay? So that when we get a new data point, we know to what category it belongs. So the step 2 is to know that the separation line has the form y equal mx plus b. Okay? So whatever line we have here separating, it has a form mx plus b. Okay? This is something that we need to know. So the third step is to find the extreme what we call extreme separation lines. Okay. The extreme separation lines are not the optimal separation lines, are those that are separation lines but are not are in the edge. Okay, So the extreme separation lines are going to go through following points. The points, one extreme separation line is this one, okay? It separates the B's in one side and the A's in other side. So L1 goes through A3 and B3, goes through the points A3 and B3, and is a separation line, okay? So the line that goes through A3 and B3 has one line that goes through 2 points has this equation. Okay, this line goes through the points x1, e1 and x2, e2. Okay. So the point A3 is 150.68. And the point B3 is 192, 92, 192. No, sorry, this is wrong. This is 150 and this is 68. And the upper part is 192 minus 150 and then 92 minus 68. So this delivers an equation y equals 150 plus 1.75 times x minus 68. Okay. The second line goes through the points A2 and B1. So it has equation 1 minus 160 divided by x minus 60 equal 175 minus 160 divided by 85 minus 60. So it has the equation y equal 160 plus 0.33 x minus 60. So both lines, this is going to be the second line, by the way. Let me paint it. Going through the points A1, A2 and B1. Okay. Both lines are going to join in one point called alpha. The equation of this point alpha is fulfilling both lines, so I sub alpha is 150 plus 1.75 x sub alpha minus 68, and the second line I sub alpha is 160 plus 0.33 x sub alpha minus 60. So as a result we get that 0 is minus 10 plus 175 minus 0.33 x sub alpha minus 68 plus 60. So we get that x sub alpha equals 12.67, and as a result epsilon sub alpha equals 53.18. Okay, so this is our point alpha, 12.67 and 53.18. Good. Now the distance between our optimal line, let me paint it somehow. Okay, it goes through alpha, the optimal line, and this is going to be the separation line. Okay, L goes through alpha. The distance to the nearest points needs to be equal. Okay, so the distance from the line L to the point A2. Oh, by the way, the distance between one line and a point is, the equation is mx plus epsilon plus b in absolute value divided by square root of m square plus 1. Okay, the point is x0 is 0. So if the equation of the line is this and the point is x0 is 0, that's the distance between one line and one point. Okay, so that you know. So this is m times, we put the coordinates of A2, 60 plus 160 plus b divided by square root of m square plus 1. And the distance between the line and B2 and B1 is m times 85 plus 175 plus b divided by square root of m square plus 1. So 60m plus 160 equals 85m plus 175, because both distances need to be the same. M then equals minus 0.6. Because m equals minus 0.6 and the line goes through alpha, we can say, if we put the coordinates of alpha, this is 53.18 equal minus 0.6 times 12.67 plus b, so that b is simply 60.78. As a result, we have our optimal separation line minus 0.6 times x plus 60.78. Okay. Of course, if we want to calculate the distance, this is also simple. We just need to do 60 times minus 0.6 plus 60.78 plus, plus 160. I mean, it was correct, but plus 60.78 divided by square root of 60.78 square plus 1 equaling 3.04. Okay, so this is the way to calculate the best line separating two areas or two data sets. Is this plausible? Any questions? No questions? Maybe it was too fast, or maybe you want me to repeat something. It's always difficult to know. Yeah, there's a question. Yeah. You're right. Yeah. Should be you're correct. 0.6 square. Yeah. This is not correct. Let me do it again. Thank you for the catch. 60 times 0.6 minus plus 160 plus 60.78 divided by square root 0.6 square plus 1. Yeah, this is 158.45. Thank you. Yeah. Yes, exactly. Yeah. Because, I mean, this is a very approximate way to do support vector machines. When you do it with a computer, it will be a little bit different. This way is the way to understand the mechanics of the algorithm, okay? So there are other ways to do it, more effective and faster, but this is the way to do it with just pen and paper. Yes. Anyway, this was just one example, okay, with 2 dimensions, okay, x and y, and 2 groups, okay. So this is just 2 dimensions. X and y, and 2 groups, A and B, okay. But support vector machines can be implemented to many dimensions and many groups, okay. And this is a little bit trickier. So let's see an example of how this is implemented for 2 dimensions and 3 groups, okay. For 2 dimensions and 3 groups. And so the reason why I take 2 dimensions is because it's easy to paint. We can make many other, but imagine we have 3 types of customers: A, B, and C customers, okay. Their position in the customers are asking for pizza, okay. So their position in the map is 0, 0, 0, 1, 4, 0, 5, 0.5, and then 2, 4, and 3, 3.5. Okay, so this is the positioning, and we want to separate the map of the city to if another customer comes, so that we know with which customer type what delivery service should act. Okay, which guy should we call, with which area should we allocate. Okay, so if we paint this in the map, let me explain you the logic of this. Okay, because it's a little bit different than what we just did. I mean, it's related, but it needs a little bit of change. If we paint these customers in the map, then we have 0, 0, which is A1. Then we have 0, 1, which is A2. So these are the customers A1 and A2. Then we have 1, 2, 3, 4. We have here B1. And then 5, 0.5. This is customer B2. Then we have customer 2, 4. 2, 3, 4. It's customer C1. And then 3, 3.5. It's customer C2. Okay? So the way to do it is we are going to, now please pay attention, we are going to find the separating lines between A and B. Okay, this is the line, separating line between A and B. Then the separating line between B and C. Okay, it could be like this. Separating line between B and C. Then the separating line between A and C. Okay, which could be like this, I don't know. Okay, this is a separating line between A and C. This is going to deliver 3 points, a triangle. Okay, so in the middle of this triangle, this is going to be our point alpha. And then parallel to the lines given before, okay? So parallel to the lines given before are our separating lines, but going through alpha. Okay? And these are the separating lines separating the worlds, one for A, one for C, one for B. Is that cool? So this is the strategy we are going to follow. Any questions to that? Good. So now let's look at the line between A and B. Okay? This line, we take two extreme lines going through A2 and B1, and the other streamline goes between A1 and B2. So the first line is y minus 1, x minus 0 equal 0 minus 1 divided by 4 minus 0, equaling y is 1 minus 1 divided by 4x. Second line is y minus 0 divided by x minus 0 equal 0.5 minus 0 divided by 5 minus 0. Y equals 0.1x. As a result, y sub alpha 1 equals 1 minus 1 divided by 4 x alpha 1, and y alpha 1 equals 0.1 x alpha 1. So as a result, we get as x alpha 1 equals 2.857 and y alpha 1 equals 0.286. Okay. If we look at the distances, the distance between this line LAB and the nearest point A2 is equal to m times 0 plus 1 plus b divided by square root of m squared plus 1. The distance between the line LAB and B1 equals m times 4 plus 0 plus b divided by square root for m squared plus 1. Because both distances are the same, we then get that b plus 1 equals m times 4 plus b. B goes with b, and then m is 1 divided by 4. And because the line goes through alpha equals plus b, because the 9 goes through alpha, and this is 0.286 equal 1 divided by 4 times x plus b. As a result, b equals minus 0.428. Okay, so the first line AB, this is basically the same as we have done above. Okay, in the first example, 0.25 minus 0.25x, sorry, minus 0.428, and alpha 1 is 2.857 and 0.286. This is the first result. Okay. Questions? This is between A and B. So let's do the same for A and C and B and C. So the line between A and C goes through L1 goes through A2 and C2, meaning that epsilon minus 1 divided by x minus 0 equal 3.5 minus 1 divided by 3 minus 0. As a result, y is 1 plus 0.83x. The second line goes through A1 and C1. As a result, we have y minus 0 divided by x minus 0 equal 2 minus 0 divided by 4 minus 0. This goes then that 0.5x. Okay. Then y alpha 2 equals 1 plus 0.83x alpha 2. Y alpha 2 equals 0.5x alpha 2. As a result, we get that x alpha 2 equals 3 and y alpha 2 equals 1.5. Because the distances between LAC and C1 need to be the same, we get that m times 2 plus 4 plus b divided by square root of m squared plus 1 is the same as the distance LAC and A2. This is m times 0 plus 2 and plus 1, sorry. A2 is 1 plus b, the square root of m squared plus 1. Both needs to be the same, so 2 times m plus 4 plus b equal b plus 1. B goes, so m is minus 3 divided by 2, also minus 1.5. And then we have that because the point goes through alpha, we can put the numbers of alpha there. 1.5 equal minus 1.5 times 3 equal b. So as a result, b is going to be 6, right? So our line between A and C is going to be equal E equal minus 1.5 x plus 6. And the alpha point 2 is going to be 3, 1.5. Basically the same dynamics as before. This is A and C, and then we make B and C again, okay? So the line between B and C, L1 goes through B1 and C2. As a result, we get that y minus 0 divided by x minus 4 equals 3.5 minus 0 divided by 3 minus 4. As a result, we get that y is 3.5 times x minus 4. And the second is goes through B2 and C1. So this is y minus 0.5 x minus 5 equal 4 minus 0.5 2 minus 5. So this is y equals 0.5 minus 1.67 x minus 5. Okay, so as a result, y alpha 3 equals 3.5 x alpha 3 minus 4, and y alpha 3 equals 0.5 minus 1.67 x alpha 3 minus 5. Okay, so resulting is 0 equal minus 3.5 x alpha 3 plus 14 minus 0.5 plus 1.67 x alpha 3 minus 8.35. Okay, resulting then in x alpha 3 equal 2.814, y alpha 3 equal 4.15. Okay, so the distance between the line BC separating BC and C2 equals m times 3 plus 3.5 plus b divided by square root of m squared plus 1, and the distance between LBC and B1 and B2, sorry, equal m times 5 plus 0.5 plus b divided by the same m squared plus 1. So this turns into 3m plus 3.5 plus b equals 5m plus 0.5 plus b. B goes, so that m turns out to be 1.5. And because it goes, the line goes through alpha 3, we can substitute the data. This is 4.15 equal 1.5 times 2.814 plus b, resulting then into b equaling minus 0.071. As a result, the line separating b and c can be written as y equal 1.5 times x minus 0.071, and the alpha 3 equals 2.814 and 4.15. Okay? So far, so good. Good. Then we have 3 points. Let's say alpha 1, alpha 2, alpha 3. Okay, the barycenter of the triangle alpha has coordinates x alpha 1 plus x alpha 2 plus x alpha 3 divided by 3, and then y alpha 1 plus y alpha 2 plus y alpha 3 divided by 3. Okay, this is like a mean value for the two coordinates. So we are getting then, if we insert the numbers, 2.89 for the x and then 1.978 for the epsilon. Okay, so this is our point alpha. The parallel line, so the line separating A and B was y equals 0.25 minus 0.428. Okay, the parallel line going through alpha has the same slope. Oh, sorry, this is with an x. Has the same slope, but it has following equation: y, the coordinates of alpha in y, minus m, the coordinates of alpha in x. Okay, so let me write it here. The parallel line to y equal mx plus b going through x1 epsilon 1, I mean this is basic geometry, is equals e equal mx plus epsilon 1 minus mx1. Okay, so as a result, our real trend separating line for our problem equals y equals 0.25 x plus 1.256. Okay, so this is 1/3 of the solution. The same thing we do with A and C. So y equal minus 1.5, no? Minus 1.5 plus 6. So the parallel line to this going through alpha is y equal minus 1.5 x plus 1.978 plus 1.5 times 2.89. So the parallel line LAC in our problem is y equal minus 1.5x plus this number, let me do it, 1.978 plus 1.5 times 2.89 equals 6.313. Okay, this is the second solution of 3. We need to calculate the 3 separating lines. The separating line between B and C was y equal minus x plus 4.5. The parallel line alpha going through alpha is y equal minus x plus 1.978 plus 1 times 2.89, so that LBC in our problem is y equal minus x plus 1.978 plus 2.89, so 4.868. Okay. And these are the 3 equations of the 3 lines going through alpha that are represented here in green. Okay, any questions? This can be done for 3, for 4, for 5, for 6, for 7 dimensions. The only problem is if that is done, then we cannot represent this graphically, and to do it is just a pain in the ass with a piece of pen and a paper. That's why I think this is enough for our goal to explain the support vector machines. Okay. This method can be combined with other methods like deep learning. So you can use support vector machines with deep learning or with clustering algorithms. So imagine imagine I would not give you the customer classes, okay? So you only would have just the points. The first thing to do if you want to implement support vector machines is to do a clustering algorithm before, okay? So you would need to implement Cummings clustering, for instance, to find out what are the clusters first, okay? And this could be asked again in the exam. I could just say, here are some points, okay? So make sure you cluster them. Once you cluster them in 3 groups, then give me the support vector machines lines for our cluster. Okay, so you would need to perform the cluster and then the support vector machine. Okay. So this is important. This method is important for business because Of course, you can have, here I give you weight and height, but I can give you cost and quality, okay? So you can, with this method, you can cluster, you can define regions in your KPI phase room, phase space, to say, okay, with this new customer, it behaves like class A, class B, class C, okay? So this it's a very important method actually. This is done with one line of Python, so it doesn't really matter. You would not need to know, but I think it's important that you understand how algorithms work in the mathematics. Later on, you will just need to implement them, and to implement them, we use Python. Okay? Anyway, any questions?